In our next session, I'm going to take a look at one of the most important components of the Cisco Identity Services Engine, the policies. We will start this session with an overview of the different policy types. Then we will move on and talk about the policy elements. I'm also going to discuss the policy sets. And then to finish, we will go over authentication and authorization policy. And this is going to be eventually the focus in this session. And since ISE is a policy-based system, the actual services offered by the platform will be controlled through policies. Examples of policies that we will see on ISE include authentication, authorization, a poster, profiling policies, and more. As I briefly mentioned, at some point in this session, we will eventually focus on these two. This is going to be authentication and authorization. The poster, profiling policies. Some of these we will take a look at in other videos. Where poster, this is a slightly more advanced topic. I'm going to leave it for a different course. You can find more information about this type of policy in the Advanced Identity Services Engine video series. Right, the most important thing, one of the most important things to remember about all of those policies is that in vast majority of cases, they will be processed in a top-down fashion. So we will have a bunch of roles inside of those policies, and we will process them one by one until a match is found. So if I have a match in the first role, I'm gonna leave the remaining portion of the policy. Only when I don't have a match in the role, I'm gonna move down to the next role. Okay, if I have a match here, I take an action associated with the role, and I am not processing anything further. Now, if I don't have a match in my custom roles, in many cases there is gonna be a default role, which is meant to act as a catch-all. You can also modify the content of this role to enforce your policy or basically to take a certain action. And this is going to apply to most policies. In certain cases, it might be possible that roles will be combined. But if this is going to be the case, I'm going to point it out. As we will see later, there used to be one option called multiple match or multiple matches. In the authorization policy, this was before 2.3, that allow you to match multiple roles, but this is now deprecated. I'm going to get back to this topic when we discuss the authorization policy. Once again, in vast majority of cases, the policy is going to be processed top-down until first match. Okay, there are two main pieces of information, two components that you will see inside of pretty much every single policy, which is going to be the conditions and the results. Conditions is something similar to the iOS class map matching criteria. It defines the, in this case, flow or just the session or basically a certain type of information we want to match to eventually perform an action. Result is an equivalent of the iOS policy maps action. Again, conditions define what I'm trying to match. And if I have a match, I'm gonna take an action. This is gonna be my result. There might be also multiple actions what you can define in certain policies. It will eventually depend on the policy type and what you're trying to accomplish. Okay, one thing that is not listed here, but it makes sense to at least mention this, is the policy, I would call it policy specific element or just component. Policy specific component or just element is something that is not really a condition and not really a result, but you may find it in certain policies. Now, some people will actually classify it as a condition, but some others won't. An example of a policy-specific information is a certainty factor. This is something that you will find inside of the profiling policies. You can think of that as of a condition, special condition that controls whether the policy is matched or not as a whole, but it's not something that you will specify inside of the policy rules. Right, now moving on, let's take a look at the policy elements. There are actually multiple predefined elements that you will find on ISE under policy elements section. We will see a bunch of conditions and we will see a bunch of results. Now, which of those you will be actually using is going to depend on the policy type. We have a bunch of conditions defined under library. This is sort of like a special use case. We will talk about the library in just a second. But you see, we've got a separate section for posture. We've got a section for profiling. There is also time and date conditions, what you can use, what you can define. And then we've got results for authentication, authorization, profiling, posture, and client provisioning policies. So as a rule of thumb, we've got separate different types of elements for different policies. Now, an important thing to understand is that most of these elements that you can find here under policy elements, the structure of these is not arbitrary. Okay, they are the structure of these elements is actually it's made of so-called objects, where objects are defined inside of ISE dictionaries. A dictionary is basically an additional structure, sort of like a database, like a catalog that is maintained by ISE, which ISE uses to understand information received from external sources, such as radius packets. So ISE knows how it can use it, so it can expose this information to the GUI, so we can eventually use this information as we build our policies or other ISE configurations. And this is the dictionaries, you can find them over here. We are still within the policy elements. Now, a dictionary, as I said, is basically a collection of objects where those objects are made of attributes and values. We take a look at the attributes for the device dictionary. We have 1, 2, 3, 4, 5, 6 different attributes. Each of those attributes is meant for a specific purpose. And now we take a look at one of the attributes. This dictionary also stores values that can be used or just selected for this attribute. So this is how ISE knows sort of like what's the device in this case and what information can be used to describe a device. There are multiple dictionaries that ISE uses. And there is also, let's see, another important one is going to be radius. Actually, many of these are important. What dictionary we will rely on will depend on the configuration we plan to deploy. Okay, the dictionaries are broken down into two sections. We've got system and user-defined dictionaries. There are multiple entries inside of the system dictionary, inside of this catalog. The user dictionary catalog is empty by default. The difference is that the system dictionaries is something that we can only read, but we cannot modify them. If you plan to add, if you plan kind of like to teach ISE about certain data, and maybe you've got a device coming from a different vendor, non-CISCO vendor, and this device sends some information to ISE, which is going to make raw data that ISE doesn't really know what it means. If you plan to use this information in your policies, assuming that ISE supports a dictionary that you could, building a dictionary that could do the translation between the raw data and something ISE can understand, I'm going to call it objects. And that would be an example of a dictionary you would want to add to this user catalog. If you think about, let's say, radius, which is, let's go back one step. Let me open up the system catalog. We've got a bunch of dictionaries here: NetFlow, posture, profiling, TACAC, session. There is also one for radius. What is this one for? The radius dictionary is used by ISE to teach ISE about the different attributes a radius packet can carry, so that ISE can translate the actual numbers, the radius bits, into objects, which is something that we will then use exposed to the GUI so we can work on this information. Let's go and check the IETF radius attributes. Let's just say IETF radius. I'm going to say CISCO. Let's take a look at one of the CISCO configuration guides for radius. We take a look at the radius packet format. This is the actual header. We see that a portion of the radius header is dedicated to the attributes, and also, which is not shown here, to the actual data stored within those attributes, our values. If we take a look at one of those attributes we can carry, let's say number 6, this is technically known as a service type. And service type can be one of 9, it can take one of 9 values, from login to callback alias prompt. Okay, so the reason why we have those dictionaries is that when ISE gets a radius packet, or if this is going to be radius header, and this is going to be our attributes portion of the header, assuming that we see something like this, 6, and then the value, let's say 1. If we didn't have radius dictionary on ISE, this is something that ISE wouldn't be able to, well, it would be able to read it, but it wouldn't really understand what the 6 and 1 mean. And this information is something that we would probably never see inside of the GUI. So ISE doesn't know what's 6 and then what's 9 inside of the attributes in the radius header. It's the dictionary what it does the translation between the raw data. It takes raw data and it translates it to something that ISE can understand, which is the objects, which is then something that we will be able to refer to as we work with ISE. That's the purpose of the different dictionaries. Now, as you work with ISE more and more, you will also notice that some of the elements, like policy elements or a certain information, certain components of the policies, basically a bunch of other data that is available on ISE, is not part of any dictionaries. The reason for that is that ISE also relies on some external sources to obtain the let's call it objects, the data it will eventually understand. It fetches this data in most cases from the CISCO's websites. An example of such information is poster updates, or maybe certain profiling policies. It downloads this information from external systems. Right now, as I said, the dictionaries, this is something that you can modify as long as you work with user catalog. The system dictionaries are read-only. As you get to the point when you start building your policies, configuring policies, you start adding rules. Those rules are made of conditions and results. You will have to, at some point, well, at least modify the existing elements, or in most cases, you will also have to add some new ones. In case of the policy results, this is something that you will do from the results section of the policy elements. No special considerations about this portion. But if you plan to work with conditions, these are generally accessible from the so-called Condition Studio, which is a part of the GUI. It's this window over here, made of two sections. We've got the library on the left and editor towards the right. Now, if we take a look at the editor portion, this is what we use to build our conditions. I have the dictionary I can choose from. Let's say I want to build a condition that is gonna it's gonna match something from the radius packet. It's gonna be the radius dictionary. I'm choosing the dictionary over here. Okay, I can also specify, put the attribute here if I know its name. This is basically a filter. Or I can also choose the category of the attributes I want to look at within the radius dictionary. Like if I click on network device, we've got these two attributes that are relevant to network devices. If I click on the port, we've got those attributes that correspond to radius ports. We also should see the session. Okay, there is nothing in the session here. Subject is 1. Time. Okay, we've got some unclassified attributes. But the idea here of those icons is just to break the attributes down based on certain information. This is fixed. You cannot add, you cannot modify those icons. Of course, you can also find the attribute here, as I said. It's up to you. If you don't know the attribute name, you will probably want to choose one of these to narrow down the scope of what it shows you here. And each of those, it is also going to tell you what value the attribute takes, the type of the value. Now, if I were to build my own condition from scratch, let's take a look at device. A network device. Maybe let's look at something else. I'm gonna close this. Again, I'm gonna add a new condition. I need to select the attribute I wanna use to make the condition. Let's say I wanna focus on the device dictionary. I'm gonna choose the device type. Let's actually see if I can. Okay, I'm gonna select the device dictionary, and we will try to find the network device. So this is showing me the device attributes that are associated with the network device group, network device catalog, which is based on this icon. If I disable this icon, it shows me all device dictionary attributes. Now the question is, where do we get those attributes from? I can select one of these to build my condition. I can select device type. I can say how they want to do the classification. Is it supposed to be a match? Not a match? Maybe I'm looking for a string inside of this, the value stored in this within this attribute. And then I can also, possibly I can also select some values from the list. So the question is, where do we get those attributes from? It's the dictionary. It's the dictionary because, as I said, ISE must know the objects so it can present the data inside of the GUI. So if we were to go to the system dictionary, if we were to take a look at the device entry and then the attributes, which I can also show you here, it's all based on the content of our dictionary. This is why I can actually choose one of those attributes. Okay, now as we build the condition, selected the dictionary, I selected attribute. It is also possible to combine those using the mathematical Boolean logic. Let's choose something here. And let's say we want to add another one. So you can build more complex conditions by combining multiple rules within a single condition. I can go for a different dictionary. I can choose the same one. Maybe this time let's try to find radius. Let's choose just one of these. It doesn't really matter what. Okay, so the dictionary is also going to affect the options you will see here, and of course the actual values. Notice this option here. This is how you will control the mathematical processing, the processing, I should say, of these conditions, of these rules, I should say, within a single condition. Do you want to combine them, have a match when I meet both criteria, or maybe just one of them? I can also build subconditions. So the logic of the individual conditions can get really complex. Of course, at the end of the day, it depends on what you are trying to do. You can even change the processing from is a match to it's not. So this whole logic can get really complex, and it may take multiple inputs to finally define a condition. But the good thing about it is that it is also possible to save those conditions to the library for further usage. Like when you plan to use this complex condition multiple times, you may want to say save. Let's get rid of this one. You can say save. You can give it a name, my C1. You can give it a description. When I save it, I should be able to find it inside of the library. And now, if I want to add it within the policy, I can simply drag it and drop it to the editor window. So this is what the Condition Studio is for. And as I said, it's going to be much more, the library is going to be much more useful as you get to one of the policies. This is just a quick example to show you what's going to happen when you add a rule within one of the policies. Let's say add a rule. When I click on the conditions, I can now take this information from the library and use it to construct the rule itself. Another thing I want to take a look at in this session is policy sets, which is what allows you to group authentication and authorization policies into separate entities. And this is what is by default enabled in ISE 2.3 and above. If this was older versions of ISE, this was optional. And then in very old versions, it wasn't even possible to use this feature, which meant that you were dealing with just one authentication and one authorization policy, and this was global for the entire ISE node. Okay, so the purpose of breaking these, actually tying authentication and authorization policies together into a policy set is just to simplify the policy structure. If you think about those older versions of ISE and one authentication, one authorization policy, the more rules you are adding to those policies, the less readable they became. And the more complex it was to troubleshoot the system when something was going wrong. With policy sets, you can come up with multiple authentication authorization policies, each tailored to a certain purpose, such as type of access, wired, wireless, guest, maybe location of the devices involved in the communication, and so on. If we take a look at this on our ISE, we will go to policy sets. By default, you will see just one policy set called default. I added some entries in one of the previous sessions to show you some more examples. But originally, it's going to be just one policy set called default, which is not associated with a condition. Now, the custom policy sets must be always defined with at least one condition, the main condition, which is what is used to ascend the session to the given policy set. Because the policy sets, for those of you who were familiar with ACS, the policy sets is basically the ACS's equivalent of service selection rules. The idea is to evaluate the connection at a high level, looking at those different policy sets. We will evaluate those top-down until we have a match. And only when we have a match for a policy set, we will eventually divert the session to the authentication and authorization policies defined within this set, which is here. Okay, so we process those policy sets top-down until we have a match. If we don't have a match with custom policy sets, we're gonna fall back to the default policy set. And each of those policy sets is again just a compilation of authentication policy and authorization policies. We actually have few sections for the authorization policy. I will get back to this concept in this session. What I want to tell you now is that for the policy set to be eventually processed by the Identity Services Engine, the network access service, if network access service configured for the set is defined as the allowed protocols, the protocol used by the connection by the session must be accepted within this allowed protocols list. What's allowed protocols? It's basically a list of protocols we agree to process for the session. And this is something we should be able to find under policy elements results for authentication. The default network access allows for pretty much everything. Well, a lot of different protocols are by default enabled, accepted by this list. We've got the authentication bypass, host lookups, PAP, EAP-MD5, EAP-TLS, PEEP, EAP-FAST, EAP-TLS, and so on. So this component here is used to save resources on our ISE, because in many cases an organization is only going to choose a bunch of these protocols for connections. So for instance, if you know that EAP-FAST is never going to be used in your network, you may want to create a custom protocol list, or basically modify this default one, and disable EAP-FAST by unchecking it over here, which is gonna save resources by simply rejecting the connection at the very first processing level. Instead of negotiating EAP-FAST and then figuring out that you don't really use it, that your device doesn't support it, you might want to cut down on the negotiation at the very beginning here. As an alternative, you may also want to use a so-called radius sequence, which is how you will proxy the session that would normally end up in this policy set to an external radius server. So if the session is to be processed by ISE, it means that it must be, the protocol involved in the connection must be on this list. If it is, we will eventually proceed to the authentication and authorization policy rules. Okay, so assuming that we have a match with one of those sets, the protocol for the connection is on our list. We go to the set itself and we start processing the rules top down until we have a match. So we will process the authentication policy rules first, because remember that authentication always happens before authorization. In order to process authorization rules, we must pass authentication, or at least be allowed for the authentication policy to move on to the authorization rules. So we go top down until we have a match. The authentication policy, as you can see here, consists of just one default rule. And then as we get to authorization policy, we will still process the rules top down until we have a match. Okay, I'm going to explain the structure of those two policies in detail in just a second. What I wanted to focus now is the general processing of the policy sets and then the rules within the matched policy set. Also notice that policy sets are available for device administration. If we go to Work Centers policy elements, you've got separate policy elements for device administration, and we've got a separate policy sets, which is the same exact logic as network access policy sets. The only difference here is that if I say add, instead of using radius proxy, you might want to choose a TACAX plus server sequence. Like if you plan to handle the connection using some external TACAX plus servers, not this ISE. Right, let's now talk about the authentication and authorization policies. Authentication policy is also abbreviated, sometimes abbreviated as AUTH-C, or authorization policy is going to be abbreviated as AUTH-Z. You will sometimes see this notation in my sessions and also in the documentation. Okay, the purpose of the authentication policy is to establish an identity, so to bind the session to an identifier, which is something that we can then act on as we process the connection further. As I said, the roles within the authentication policy are processed one by one top down until a match is found. By default, we take a look at one policy sets. Maybe let's take a look at the default policy sets. We should see just one authentication rule. I'm going to the default policy set. I'm opening the authentication policy. Okay, the default authentication policy actually consists of 3 rules. But we see that this default rule is still at the end. It's acting as a catch-all. Now, when we have a match with the rule, so either here, or with the default rule, we will now have to process the rule. And what we're going to start with is by trying to find a matching identity store, which is a database that we will use to authenticate the connection. The database can be defined as a single entity, like internal endpoints database. This is for devices, or maybe internal users, maybe a single Active Directory system, or in many cases, you will also see a so-called identity source sequence, which is a combination of multiple databases. Let's take a look at this. So it is possible to specify more than one database to tie those databases together into a source sequence so that they will be checked one by one from the first up to the last one. And if we take a look at this default all user ID stores, we see that it consists of 3 databases: internal users, Active Directory databases, and then guest users database. So we will try these one by one top down, assuming that we selected it for the role like what we see here. Okay, assuming that authentication was successful, we will of course pass the validation. If the user was not found or authentication wasn't successful, we will fail it. What is going to happen next after authentication? If authentication was successful, we will finally get to the authorization policy. If authentication failed, it could happen because of 3 reasons. Well, either credentials were wrong, or maybe the user entry was not found in the database, or we had a communication problem and the entire process failed. And for those 3 cases, ISE gives you a chance to specify how to handle this situation. You can either send a reject packet to the connecting client, to the NAD, to tell it that authentication failed. You could potentially silently drop the packet, which is going to cause the client, the NAD, to assume that the Radius server is dead or has some sort of connectivity problem. Or you can go for the continue action, which is how you say that no matter what's in the database, you allow the connection, you move the connection to the authorization policy. Okay, this continue action is not going to work for every single protocol. The common use case for this action is when you deploy so-called web authentication. Now, what is going to happen inside of the authorization policy? What is the purpose of the authorization policy, abbreviated as Z? The purpose here is to determine the level of access to grant to the connecting user or device, either to the network or to the device for administration. So we can limit access to the network, like maybe assign a user to a certain VLAN. We may want to control communication through an access list. There are several different ways as how we can do the enforcement, and we will look at this stuff later in this session. But what I want to focus on first is the structure of the authorization policy. Because as we saw previously, the authorization policy, let's go back to one of the sets. There are actually 3 sections as where we can add our authorization rules. So this is logically broken down into 2 rule types. We've got the standard rules and we've got exceptions. We look at this on ISE. This portion here, this is going to be our standard rules versus global exceptions and also local exceptions. This is our exception rules. Okay, what's the purpose of the standard rules? This is something that you will, so this section here, this is something that you plan to use on your ISE long term. It's regular stuff, which is what you use to build and enforce your policies. Versus the local exceptions is, and possibly also global exceptions. This is what you will normally deal with as you plan to add your temporary rules. Rules that you don't want to leave for longer. Maybe you want to test a certain policy for a session or connection, or maybe there is some sort of a problem in the network, you want to fix it as soon as possible. One way to solve it would be to add an authorization rule to one of these sections. What's the difference between the local and global exceptions? Okay, whatever you will put over here is only going to affect this single policy set. Now, as you add a rule to global exceptions, this rule is going to be populated within all policy sets on this ISE node. Let's take a look at this. Just to make it clear, I'm going back to the policy sets. I'm choosing just one, let's say default. I'm going to the global exceptions. I'm adding a single rule. Let's choose a condition, doesn't really matter what. I'm choosing a result. I save. When we now get back one step, we have one role in the authorization policy global section within the default set. As I now go back and check the other policy sets, this role is also here. So it's global meaning processed, used by all policy sets on this unit. If I were to add a local rule, it is only going to affect this single policy set, but not the other ones. And as you probably guessed, those rules will be still processed top-down. So exception rules, since they are higher in the policy, they will always take precedence over the standard rules. We check the rules top-down, and we use the first match logic. ISE systems prior to 2.3 code, they also gave you the multiple matched option that modified this top-down first match logic. It allowed you to combine roles. It allowed the system to process all roles, combining all which matched. And this is now deprecated. The only way to process the authorization policy is top-down first match, same as authentication policy and policy sets in general. Okay, as a result of a match in our authorization policy, we will eventually take an action. We will push the so-called authorization profile to enforce our policy. We've got several profiles predefined on ISE. this stuff you can find in other policy elements results for authorization. So this is what we will enforce on the connection. And now specifically what can be enforced, just to quickly look at the methods, we can either push an access list. So we can define an ACL on ISE and push it for the session to limit the communication. And we can also assign the connecting user or device to a certain VLAN. We can enforce web authentication for systems that support the web browser. And we can either do it on the connecting client, which is the local version of this feature, or we can do the authentication on ISE. This is known as Central Web Authentication, CWA. As an alternative, it is also possible to use advanced segmentation with TrustSec by enforcing security group tags, SGTs, and of course anything else that you can push for radius AV pairs, including CISCO custom VSAs. You can also enforce this policy. If we take a look at the structure of the authorization profile, I'm going to say I want to add a new one. It's all about the attributes that will be sent within the radius packet, what we can enforce. And the common task section here, it basically simplifies working with those attributes. For instance, if I were to say I want to push VLAN 80 for the session, we see that ISE automatically translates this information to radius attributes. If I choose a MACsec policy, this is what we can enforce using the CISCO VSA, the CISCO AV pair. So anything you select here, this gets translated to the attributes. If there is something you want to push which is not on this list, you can use the advanced attribute settings over here. You can select a dictionary, choose the attribute, set a value, and ISE is going to automatically include this information in the packet and send it to the network access device to enforce the policy.